All right, so based on the videos, the first question was, what is the name of our galaxy? You should know that. You should know that from elementary school, right? It's the same name as a candy bar. And then what shape is our galaxy? We looked at the video, and it said that there's three different shapes. The three different shapes are irregular. Irregular means there's really no shape. Kind of like if there's a bug and you step on it and you pick up your foot and it's just flat, that's irregular shape. There's elliptical. Elliptical is kind of it means like an oval or an egg shaped. So an elliptical galaxy will look like a big bright spot, kind of an egg-shaped spot. And then there's spiral galaxies, which looks like water going down a drain, or as the video showed, kind of like a pinwheel going around and around and around. So who can tell us the name of our galaxy and the shape of our galaxy? Yes, the Milky Way is the name of our galaxy. Now, the candy bar is named after us, not the other way around. We didn't name our galaxy after a candy bar. The candy bar named itself after a galaxy. Right, don't worry about it. We'll fix it. And then we are a spiral galaxy. Okay, we are a spiral galaxy. And in fact, there we go. Okay, go ahead. And in fact, we live on one of the arms of that spiral galaxy. Okay, one of the pinwheel parts of the spiral galaxy. Okay, so Milky Way and spiral. That is our galaxy. Next, what are two things? What are the two main things that affect gravity on another object? What are the two things that affect gravity between two objects? We should know this by now. We learned it in forces, and we learned it here in astronomy. It's two things that affect gravity. Yes? No, that's a force, not magnitude and direction. Think about it for a second, right? Does the moon have the same amount of gravity as the Earth? No. Why? Because the moon is smaller, less massive. So mass determines something's gravitational force. I mean, think about it. The Earth is larger than the moon, so our gravitational force is larger than the moon. If we go to the moon, we weigh 1/6 the amount of weight that we weigh here, right? So if you weigh 60 pounds here on Earth, you'll weigh 10 pounds on the moon, because gravity's effect is 1/6 that of the Earth, because that size difference is 1/6. But now look at the sun. The sun is the most massive thing in our solar system. It's so massive, its gravitational force can hold not only the planets, but the planet's moons and asteroids and everything else in our solar system, because it has such a massive gravitational force. Okay? So mass determines gravity. But one more thing. What's the other thing that determines gravitational force? Why do we get pulled towards the Earth and not get flung off and pulled towards the sun? Why? Distance. So distance is the next thing that determines gravity. The closer you are to an object, the more gravitational force it has. That's why we don't get pulled off to the sun. Even though the sun has way more gravitational force than the Earth, we're so close to the Earth, we're on it, that we're being pulled towards the Earth. Okay? So keep that in mind. Mass and distance. What stellar process, stellar means star, so what process in the star is what makes it produce light and heat? We saw that in the third video. Nuclear fusion. Jordan, you know what nuclear fusion is? Well, what does nuclear mean? Have we learned about something that has a nucleus? What? An atom. So, and where is the nucleus? In the middle. And what does it contain? No, protons and neutrons. Now, what does fusion mean? What does fusion mean? What does it mean to fuse something? To put it together. There's a restaurant over there by Target called Thai Fusion. And it's called Thai fusion. It's because it's Thai food fused with other ethnic foods. So they bring the two together, Thai fusion. So nuclear fusion means to take nuclei of different atoms and bring them together. And it's a matter of fact that when you do bring nuclei together, they release a large amount of energy in the form of light and heat. So in the star, you have massive amounts of nuclear fusion. And that fusion is between hydrogen atoms. So you have hydrogen, which only has one proton, and most of the time it doesn't have a neutron. Remember, that's the only one that we know of that doesn't have a neutron, because once again, what are neutrons used for in the nucleus? What do we use neutrons for in the nucleus? Right? Think about chaperones at a dance. Why are there chaperones at a dance? You have no idea why there's chaperones at a dance. To make sure the kids don't get in trouble. Yeah, right? You don't want them to get in fights or anything like that. So you have chaperones to make sure you're buffering them. Hey, calm down. So that's what neutrons are for. Remember, neutrons are there to make sure the protons don't get angry at each other, because they're both positive charges, right? And we know that same charges don't become attracted to one another. They want to repel each other. So neutrons are there to keep the protons all right. Since there's only one proton, there's no need for a neutron. Occasionally you'll get a neutron there, but most of the time it's just a proton. What happens when you bring two protons together? What's its atomic number become? Larger. But what? If you have one proton and they smash into each other and now have a nucleus of two protons, you have a new element, and that new element is helium. The sun, every star, is a gigantic helium factory. They're producing helium. Every star that you see is a helium producer. Think of it as a factory making helium. And the ingredients for helium is hydrogen plus hydrogen. And the only way for that to happen is if they smash into each other with enormous pressure and speed. That's nuclear fusion. Has anybody ever been to a crash derby? What are those called? Where they take cars and they crash them into each other? A demolition derby. Anybody ever been to a demolition derby where they take cars and just run them into each other? They're pretty awesome, but this is what would happen. If a demolition derby was a sun, and each car was hydrogen, then when they smash into each other, not only is there a gigantic explosion, but out of the middle, once you see the dust settle, the two cars are gone, and a Lamborghini pulls out, unharmed. The two cars smash into each other, releasing tons of energy, and then something new comes pulling out. That's what's happening in the sun. It's a gigantic demolition derby of hydrogen producing explosions, and then a new thing called helium. That's where we get all of our helium from the sun. So next time you're at a birthday party and you see balloons floating in the air because they're full of helium, you can thank the sun. The next time you inhale that helium and talk like Mickey Mouse, you can thank the sun in a very high-pitched voice. I know. And finally, why are meteors mistaken for shooting stars, right? Sometimes you lay out, I don't know if you guys do this at all, but you should. Over the summer, please try this every once in a while. Get some friends together. If you have a trampoline or you just have a backyard hangout, a little fire pit, whatever you may have, or go to one of those local little neighborhood parks and sit on the slides and just hang out. Just hang out and look up for a little bit. Right? Don't be looking at your phones all the time. Look up for a little bit. Understand, that's all our ancestors had for thousands of years. It's only been recently that we have all these handheld devices. Okay? Just look up. Look up at the sky, and occasionally you'll see something streaking across. And what do you call that? Shooting star. And what do you do when you see a shooting star? You make a wish. But understand, stars don't fall out of the sky. Okay? The only time stars are no longer there is when they end their lifespan by exploding. It has nothing to do with a shooting star. Shooting stars are not stars. They're meteors. Why do meteors produce light. Why do they look like stars? Does anybody know? Yes, the atmosphere. And what is our atmosphere made out of? It's one of the states of matter. One of the states of matter. We have 3 states of matter. Gas. Our atmosphere is made of gas, mainly nitrogen, but also oxygen and a few other gases. Gases are atoms, and all atoms have what? Starts with an M. All atoms have mass. Okay, even though you don't feel the air around you, if you do this, you can feel it. If you can flap your hands like a bird, you feel the air. The faster you do it, the more you feel it. Don't do it too much, you might start flying away. Now, no, not really. Now understand, when you're in your car, well, not your car, your parents' car, you roll down the window and stick your hand out the window and do this. What does your hand do? It feels like it's flying and like it's being held up. It is, because the faster you move, the more you can feel the mass of the air. Swimming pools, great thing to do during the summer. You jump in from the side, you're fine, but you go to the high dive and go straight down, that water feels like concrete when you hit, right? That belly flop. That's not fun. It's fun to watch, but not fun to get done, right? So the water has mass, and you don't feel it until you really smack it hard. The air is just like that. If you smack the air hard enough, you're going to get some damage, right? You're going to get friction. When 2 things rub against each other, you get friction. And what is produced in friction? Take your hands and do this. That's friction when you rub your hands together. What's being produced? What? What's being produced? Heat. Now imagine an asteroid entering our atmosphere. Remember, the only difference between a meteor and an asteroid is with the location. In outer space, it's called an asteroid. Once it enters our atmosphere, it's called a meteor. Once it hits our atmosphere, it's like slamming into water. It's like doing a belly flop, producing heat. And that heat turns into light. And so as it enters our atmosphere, it starts to burn up. Anything entering our atmosphere will start to burn up. And we see that as shooting stars. Now, there's nothing more miraculous when you see a meteor shower. They happen more often than you know. There are more meteors that hit the earth every day than you can possibly imagine. But they're so tiny that they burn up so quickly you don't even hardly ever get to see them. But sometimes you'll hear on the news, hey, tonight's going to be a very good meteor shower. And if you travel up to like Shaver Lake or somewhere high in elevation where you get away from some of the lights of the city, you can see a very beautiful light show of these meteors entering our atmosphere and burning up like shooting stars coming out of the sky. It's pretty amazing. That's why we say they look like shooting stars, because they're entering our atmosphere, and due to friction between the rock and the atmosphere, it produces light and heat. And you wish upon that. Now, everything that's in outer space that enters our atmosphere will burn up. The space shuttle, right, they just decommissioned the space shuttle program, but when the space shuttle was re-entering, that was a very dangerous part. Not only going into outer space was dangerous, but coming back, because you have to make sure that your space shuttle doesn't burn up like a meteor would. And you have these tiles made of silicon which can absorb a lot of heat and make sure it doesn't burn up. And in fact, I believe in like 2006, one of the tiles on one of the shuttles, I think it was the, not Challenger, that was in 86, it started with a C again. I'm blanking on it for the moment, but one of the tiles did not work correctly, and as it was re-entering our atmosphere, it ignited, and all the astronauts on board were killed because the tiles did not work correctly. Okay, so everything that enters our atmosphere can burn up. Before the space station, there was another space station up there called Spacelab or Skylab. And it started to fall out of the sky. It got pulled in by Earth's gravitational pull and started to break up. And everybody was worried that you'd get a bunch of Skylab on your house, or people would die because it'd fall to Earth. But the majority of it burned up. Some of it did fall to Earth, but it landed in the outback of Australia, and nobody got endangered by it. But everything will fall out of the sky. There's a lot of satellites that companies put up there that eventually fall back to Earth and burn up before they hit the ground. The space station right now has astronauts living on it right now. And they eat. They need to eat to survive. And when you eat, you have to poop. It's just a natural form of life. I mean, you've all read that book when you were little. Everybody poops. Even astronauts in outer space poop. Right? But there is no plumbing system on the space station. Where's it going to go? Right? So you kind of have like a porta potty system going on up there. But there's no porta potty cleaner guy that comes by and sucks all the poop out or whatever they do. I don't know. You have to watch one of those Dirty Job episodes to see what happens to it. But there's none of that. So they came up with an idea. How about we freeze dry all of our poop and then shoot it out the space station and shoot it towards the Earth? Because as we all know, everything burns up as it hits the atmosphere, and it does. You don't ever notice it. You're more in danger of getting poop on you out on the amphitheater from the seagulls than the astronaut poop falling on you. It burns up. But I do want you to be aware, the next time you wish upon a shooting star, you might be wishing upon some poop from the space station. Just keep that in mind. Okay? So that's the answer to number 3. That's why. Don't worry about it. All right, any questions on these questions? Question. We just answered number 4. It's friction between the meteor and the atmosphere.